I'm going to do most of my work today just in the JavaScript console. So I'm going to be just typing in JavaScript and evaluating it right in this console. So just like when we're in IRB in the Ruby world, or when we're in the Rails console and we have ourselves a read, evaluate, print loop or a REPL, well, this is the REPL for JavaScript, right? And there's an equivalent in the Node world. There's a Node command that brings you into the Node REPL as well. But this is where I'm going to do my work today. I'm going to define data within here. We get persistent state for our variables, and then we'll sort of manipulate some of our stuff within here. So I'm just going to be interactively demonstrating some JavaScript today within here. And I'm going to pull up some of my notes on my screen here, on my second screen, and we'll start digging in. So this is me going over the things that I realized everyone should know about JavaScript before trying to learn React. So things that'll crop up in React tutorials and in React user documentation, and just in, if you're reading other people's React code, these are the things that I feel you gotta know. And it's not all inclusive. I'm not showing absolutely everything, but I tried to show most of the most common things that you'll run into. And we're gonna start with functions. And so this is a function. There are many others like it, but this one is mine. And I will define it. I've defined it with a name, and I can call it with a name, right? So this is the standard function style that we taught you in WebDev 1, where you use the function keyword, and then after the function keyword, you provide a name for the function, an optional parameter list for the ability to pass arguments into your function, and then the function body inside of curly braces. And then we call that function by name, followed by curly braces, and then again, we can optionally, if the function calls for it, pass arguments in there. And so I can do just that. Nothing too surprising there. That said, sometimes when we have a function defined, we might want to pass that function around like it's data. And so we might want to pass it as a callback to another function. And so there is, just as an example, I'm going to use the set timeout function. And for the first argument of set timeout, it can take a function. And the second argument of set timeout takes a delay in milliseconds. And I'm going to put 2000. So that's 2 seconds. So what should happen here is that set timeout should execute and then go away. And then in 2 seconds, what it'll do is it'll execute the snail function. Notice I'm not putting snail in with the parentheses. If I put snail in with the parentheses, it would execute immediately in line, and that's not what I want. I want a callback, right? And so again, this isn't going beyond what you learned in WebDev 1. This is just a fairly common way of passing a named function into a method that takes a function as an argument. 2 seconds later, hello, snail, done. The other thing you saw in WebDev 1 was that you could create callback functions, and they could be anonymous, so unnamed. And so here is an example of using set timeout. And this right here is a unnamed function, also known as an anonymous function. And so we still use the function keyword. We still have the ability of creating parameters inside of parentheses, and our function body is still inside of curly braces, and it could be multiple lines. This one just happens to have only one line in it. And here I'll say in like 2.5 seconds, I would like this anonymous function to execute. Oh, and I guess I have to not have a syntax error in the fact that I need to close the log. Hello, mail. 2.5 seconds later, it executed. In terms of set timeout here, there's no way now to retrieve this function, right? It doesn't have a name, set timeout's not holding on to it because it's not going to use it again. It uses it once, and so that function is gone. It didn't need a name. We just used it in line, and then off it goes. Sometimes you'll have like there's set interval, and set interval will call a function over and over and over at a particular interval. And so it'll hold on to the reference to the anonymous function and call it over and over, whereas set timeout just calls it once and then so that function disappears. The other thing that you may not know about is that these kind of anonymous functions can actually be assigned names and called like named functions. And so I could go like this. I could say let a variable called nail equal an anonymous function, like that. And inside of this anonymous function, I could put the following code, like so. And so the function is anonymous at this point, but I am assigning it to a variable, and so it's getting a name through that assignment, which gives me the ability to call it afterwards by name. So although it began its life as an anonymous function, I've now given it a name through variable assignment. And I can call it like so. Hello, nail. And these kind of anonymized named, so they're anonymous but then named functions, they can also be used with set timeout or any other function that takes a callback, right? So I could pass nail in there, and in 2 seconds it'll call that.
Kyle, why? Why? Like, what's a named anonymous function? Like isn't that a function? Like, what? Is it an encapsulation thing? Is it like a? No, yeah, it's not like an accessibility thing, is it? Like,
no. So like this whole idea of like the ability to have an anonymous function and assign it names, you're not going to see it in this context very often, but it is often used to attach functions to objects. Because in JavaScript, we don't just, we don't have regular old OO. Like they just added the class keyword into JavaScript. And so you can create a function within an object. So I could say an object, my object equals, and then I could say my function, and then I could assign that to an anonymous function and then make it do some sort of thing. And then now I have what looks like an object that I can make a function call on, and then it looks a little bit like OO. So we don't build objects in quite the same way in JavaScript, at least historically, because JavaScript has what's called prototypical inheritance rather than class-based inheritance. So that's mainly why we have this ability to create anonymous functions and then later on give them names. And so in a lot of React code, you will see the use of like creating functions, but then assigning them as properties of an object. Does that make sense?
So again, I'm going to the let variable equals anonymous function. I'm thinking that's the syntax that I'm talking about. I don't see, so like, it's just, isn't that the same as defining a function, or is it like the let part is different?
It almost is. It almost is identical, right? It's just another way of doing the same thing. Like if we had just done function nail like that, it would be the same thing.
Okay, it would. So there's no difference in how it's stored, how it's like yeah.
There's probably like subtle differences that I don't even know to talk about them.
Okay.
But I just started to notice this more and more, and it confused me when I first saw it.
Yeah.
And so that's why I bring it up.
I was just like, why? But yes, it's good to know that that's happening. It's good because it sounds like that happened. Also, there's a hand up. I think Travis has a question. Is that right?
That is correct. So Travis, do you have a question?
In the summer, like I was doing a bit of Node, and I struggled with arrow functions, anonymous functions, like just like that kind of stuff. Like, what is the benefit of using like each of those? as opposed to like creating dedicated functions, because I guess like if I understood the use case of like when these are good to use, then I would understand it a little bit better.
So we're going to get to arrow functions in a second. They're really just a short form of creating a function. And then they also have this extra property of the binding to the this keyword in a slightly different way. So the this keyword works sort of strangely in JavaScript. It doesn't work like this in a lot of other languages. And when you're using functions that are written in this style, or even named functions, there was a lot of bugs that would crop into code around the use of the this keyword. And so arrow functions were brought in to, one, be like a more concise syntax for functions, but also to fix the idea of how this works. And we're not even going to look at that today. Now, further to that, your sort of question is like, why we would even bother to use an anonymous function versus a name function, regardless if it's an arrow function or a regular old anonymous function. Normally, the reason for that is it's like a single use function, a function that you're not going to use throughout your code. So it's not like you're taking some code and modularizing it so that you can make heavy use of a function over and over. It's like you are interacting with a function that itself requires as data a callback function. And so anonymous functions are used for that because there's no need to name them. You just need to inline write that function just then and there, and then after that you're never going to use that function again. So it's sort of like for one-off functions that need to be passed as data to another function. So you might just have to trust me that I'm going to get to some examples where this will hopefully make more sense. I'm going to define a anonymous function, again assigning it a name, but I'm now going to use an arrow function. An arrow function is just syntactic sugar. Syntactic sugar means a little bit of syntax that makes the language just a little bit sweeter. Like Ruby is full of syntactic sugar, things that are supposed to sort of optimize for programmer happiness or whatever. And so in this example, it's not really going to make sense why I would want to use an arrow function, but I'm just using this as a way of introducing sort of what an arrow function looks like. So this right here is like absolutely equivalent to saying function and then having the same context inside of the body. Paste that in. So an arrow function just gets rid of the function keyword. The potential for having a list of parameters is still there. And then between the list of parameters and the function body, we have a little arrow, which is why it's called an arrow function. Sometimes you'll hear people call it a fat arrow function, and that's opposed to some languages that have like stabby arrows in them, right? So this is like a stabby arrow, and this is like a fat arrow. So you'll hear some people call it that as well. And if I define that, I can now call Gail. Hello, Gail. And that is our initial look at an arrow function. The next kind of arrow function I'm going to show is an arrow function where we have only a single statement in the function body. And this allows us to leave off the curly braces. And when we do this, the function becomes what's called an implicit return function. And by that, I mean that the function will automatically return the evaluation of the single statement inside of the function body. So let's define one here. I'm just going to assign it to a variable so that I can call it after the fact. And I'm going to set up an arrow function that takes two arguments. So I have two parameters defined here, a word and an emoji. And then inside of the function body, instead of wrapping in curly braces, I'm just going to go directly to what will be returned by this function. I don't need to use the return keyword because it's an implicit return. An implicit just means that the return is implied but not directly stated. And so here I will use the word, and I will also use the emoji. And I'm using template interpolation here to get the word and the emoji into a string. And so that will define that arrow function. And I could now call that arrow function. So I can say console.log, and I can call the implicit function, and I can pass into it trail, and then I will copy and paste just a emoji in there like so. And what'll happen here is trail will get assigned to word, this emoji will be assigned to emoji, and then this string template will be built with those two variables in place. It will then be returned from the arrow function. So again, that implicit return, and then it will be console logged. And it says, hello trail. And this is the equivalent of writing this with an explicit return statement like this. So this is the exact same function, but this time I have included the curly braces and I have included the return. And so we're going to see that we're going to make a lot of use of these implicit return arrow functions because of the fact that they have that implicit return. It just makes them more concise and it makes them nicer to work with in the context of callbacks. And there's one final variant of these kind of implicit return functions, and that variant is, I call it an unadorned arrow function, and it really just means that it not only does it not have the curly braces around the function body, it also does not have parentheses around its one and only parameter. And so this only works if you have one parameter. You can leave off the parentheses. One of the things I've noticed, however, is if you have Prettier, the JavaScript formatter in VS Code, Prettier will automatically put those back in for you because it has just made the decision that we should always write our arrow functions with the parameter, probably just for consistency's sake. And so I mentioned this though because you might see in other people's code, code that looks like this, and without the parentheses you might mistake it for something else, but it's still an arrow function with a single parameter, and then this function body is what is being returned from the arrow function. And then just like before, I could call it inside of a console.log, passing in this emoji, and then that will get returned within this string, and it's the return string that will then be console logged. Like so. So today we're going to see these arrow functions in a few other contexts, but there's a few other things that I want to show us first. Okay, so these sets of notes that we're going through, it's a bit of a grab bag of stuff. So we're going to take like a moment to step away from arrow functions, but I promise I will return to them and provide us some more context on their use. But we're going to just look at looping for a moment, because I'm going to put up a little bit of data that we can loop through. Here we have a fruit basket, and it is full of fruit. And so I'm going to define my fruit basket. And if I wanted to loop through this basket of fruit and visit every fruit in turn, the classic JavaScript programmer would start writing a for loop. We would, within that for loop, maybe have like a I variable that we would babysit, and we would make sure that it was less than or equal to the fruit basket's length property. And then we would have a little I++ on there, and then we could console.log the fruit basket at position I. That seems like a pretty classic for loop. And there you go. Brr. If you're always wondering, or also if you're wondering why it occasionally says undefined, that's just the console or the REPL returning what the statement that I just entered evaluates to. And certain things like assignments or for loops, as a statement, they just evaluate to undefined. And so it's a little bit noisy. I tried to turn that off and I couldn't find a way to disable that. But just don't mind that noise. The undefines are not part of the program per se. So here, there's a classic loop. But wouldn't it be nicer if we didn't need to directly use the looping variable I? Wouldn't it be nicer if we had something more like the for each loop that we have in PHP and Ruby? And the answer is we do. We have two types of loops in available to us inside of JavaScript that can serve the same purpose. And so there's our fruit basket. Here's one of the two. It's still a for loop, but inside of the parentheses, we define it a little bit differently. Here I'm going to say const fruit of fruit basket. And so the key word here is of. And so when you define a for loop like this could be a let or a const. I feel more comfortable making it a const. That's considered to be a best practice because this fruit will actually reference the contents of this array, and we don't want to accidentally change the array itself during the loop. So by making it const, we just sort of freeze access to that data. And then inside of our loop here, we can console.log the fruit, each fruit in turn from our fruit basket, and we get the same kind of output as we did before. So if we, that's just something that I know I always, when I come to JavaScript, I forget that this thing exists, and I start writing my manual loops again, and I think, wow, there's got to be a better way, and then I remember of. And so the of is a lovely way of looping. Sometimes though, instead of a regular old loop, you might want to take every element of your array and pass it to some kind of callback. And so I will show us that in action as well. And so that would look like this. I could go to the fruit basket itself, and I could say for each. And what for each takes is a callback, and it will call that callback for every element in the array. And so I could say fruit here, pointing to console.log fruit. And with such a simple callback, of course, here it's not really necessary to use the for each loop. We could have just used the of loop, but maybe you have some kind of function that takes a callback that you want to call. Maybe you want to do a series of like HTTP requests, and you fire off a bunch of things in that way. This is the way to handle that. So it's a callback based for each loop, whereas this is more of a procedural. It'll just call them one by one. Here it's going to call the callbacks one by one. The outcome in this case will be the same for both. All my fruit. And the callback that we pass to it could also be, I mean, this is just a one-liner, right? This is one of our unadorned arrow functions. But I could also pass it a function that was multiple lines. So here we have a for each. And in this example, I'm sort of adding two pieces to this puzzle. I'm also showing that if you need access to the looping variable, you can get access to it. And so I'm defining my arrow function with two parameters, and each element of the fruit basket will go into fruit here. And then this I variable, and I could call it anything I wanted to, but I've called it I, it will be assigned every index in turn. So it'll start at 0, and then it'll be 1 and 2 and 3 and 4. And then I've got a little bit of code here that's building up a string that's sort of based on the length of the fruit basket and how far we are, or sort of how deep we are into the looping. And if we run it, a pyramid of fruit, just like you'd see at the grocery store. Except at the grocery store, they might not mix and match fruits like this, but wouldn't it be lovely if you went to the grocery store and you saw a pyramid made out of kiwis, cherries, strawberries, and apples on top? That would be a lovely thing. So those that's a little bit of an aside, but those are things that crop up, again, all the time when doing React or Vue or Angular type code. I'm going to now get into a series of array helpers, and here we're really going to see the power of arrow functions, and hopefully we'll be able to better understand why we would want anonymous functions in general based on these examples. And remember, my argument for anonymous functions is that they are for functions that are like one-offs, so that we can just inline the type of processing or the type of function that we need and pass it off as a callback, and then we will likely never use that again. So it doesn't even need a name, it doesn't deserve a name, it doesn't deserve its own place in our source code, because we're not going to be reusing that functionality over and over. And so I'm going to grab this, and I'm going to define an array of objects in this way. And just so that we have this array of objects sort of present on the screen, I'm just going to, in my other window here, bring this here. And I'm going to make it so that we have this array of objects sort of on the screen at all times, so that while we're working with these, we'll have access to them. Yeah, there they are. And maybe I'll do that for now. Okay. I've defined an array of objects, and I want to show off some arrow functions, and I also want to show off just a bunch of helpful ways of working with collections in JavaScript that are going to be similar to some of the stuff we saw done in Ruby. And so we're going to be doing some finding within this array, some mapping, some filtering, some joining, some tests for inclusion, some tests like Boolean or predicate-based tests to see if every element in this array conforms to a particular test, or some of the elements in this array conform to a particular test. And then we'll also be doing a reduce operation on this array. So this is going to be the main source of our data, and then we'll do a bunch of those array things. And in each case, you'll have an example of an arrow function being used. And so if we look at our array here, every element is an object, and every one of those objects has the same set of keys with different values associated with those keys. And so we have name, emoji, legs, mana, and count. And so we're going to make use of that data as we do our filtering and joining and all that fun stuff. And so we're going to start with a map. And we've seen map in Ruby. Map is that idea that we are going to take a collection and we're going to create another collection of the exact same size, but modified in some way. And the modification process is going to be encapsulated inside of, you got it, an anonymous function represented as a arrow function. And so what I would like to do is I'm going to look at this data and I'm going to say to myself, well, I wish that I had a visual representation of these animals. For example, I know based on the data that there are 3 monkeys and 2 dogs and 5 cows. I would like an array where the first element is 3 monkey emojis, and then 2 dog emojis, and then 5 cow emojis, etc., etc. So basically taking the count and using it to repeat the emoji a certain number of times and being left with an array of animal emojis based on these counts. And so I'm going to map that data right now. So I will create my emoji zoo by going to animals and mapping. And then map takes an anonymous function. So of course this anonymous function could be written out in the regular like function style, but it'll be more common these days to see it written out as an arrow function. And so it's going to be an unadored arrow function. So it's going to have the argument like that without parentheses around it, pointing to a single transformation function that can be used with this map. And so this is what will be applied to each of the objects in turn in order to create the output object or the output array. And so it'll create each element in the array based on taking the animal So that's this animal being passed in. Going to that animal's emoji and repeating that emoji animal count times. So this is our transformation of each animal coming from our animals collection. The initial array had 1, 2, 3, 4, 5, 6, 7 elements in it, and so the emoji zoo will also have 7 elements in it, but it will be a very different type of collection. So we're mapping and transforming each element using this little one-off arrow function. So I run that. What does my emoji zoo look like? Check it out. There's my emoji zoo, and all the animals are there. I think the turkey scrolled off the screen a little bit. There we are. Check it out. So that's your first taste of why you might want an anonymous function, or even just an arrow function in general, because this little bit of code here, I'm not going to reuse it. It doesn't really need a name. It's hopefully fairly readable in its form right now. Typically when we want to give something a name, it's because it deserves a name in terms of explanation. And I'm not going to use this little functionality anywhere else in my application. So I just needed it right here in line to perform the transformation that I wanted to apply to map this collection to another collection. So that's our first example of sort of the usefulness of an anonymous function, and specifically sort of the clean style of an arrow function. Now, of course, this could have been written in the regular old way. So I could have said function animal and then pasted all of this into here. That is identical. And if you're turned off by the arrow functions, if you think that there's too many different ways in which to use them, and you find it sort of difficult to judge when to use one versus the other, you can just not use arrow functions in this context, and you could just use the functions like this, your regular old anonymous functions, and that will, as we see here, not work at all. Why, Kyle? Why is it not working at all? Do I need an arrow function here? I'm mapping. Oh, it's because of the return. I need a return like that. There we are. And so I was relying on the implicit return here that I got with having the curly braces not present. And so when I write it out as a full function, we also have to put the return in there. So the argument is that it's easier to scan this because this gets you right to the heart of things. Here's the argument, and then here's the transformation. Your eyes as a human don't have to sort of parse through and look for the return and ignore certain things. And like functionally for the computer, these two statements are the same. But there's an argument to be made that this is more readable for humans because a lot of the cruft is left out. I'm going to continue on with a few more examples here of things we can do with arrays. Filtering. And so I'm going to get my collection and filter it based on a particular test. And so I'm going to create a new variable called 4 legs good, and I'm going to go to my animals collection and I'm going to filter that collection with an arrow function, and I'm going to say filter this collection and return a new collection, but only for elements where the legs property of each animal is exactly equal to 4. And that way I can now look at my data that's being returned, and then there are the 3 objects that have 4 for the leg property of the individual elements within that array. So filtering. And the filtering, it just has to be some function that returns a Boolean. And so again, I'm relying on the implicit return here. So if you wrote it out in full function form, you would need to return that Boolean test. But again, I think this gets to the heart of things very quickly, that we're taking each animal and we're filtering for animals where legs is exactly equal to 4. We could also do some searching. And so if I wanted to find the cow, so if I wanted to find this element right here, and assuming that I didn't just have a very small bit of data where I could simply have keyed in animals at position 0, 1, or 2. So if, you know, animals at position 2 could get me directly the cow. But you need to imagine in your mind that this data is much larger and it's not just humanly readable, and maybe it would be easier for me to search it with code. And so searching it with code would look like this. Animals.find, peek at every animal and look for and find the very first animal where the animal's name is cow. Cow, there it is. And there's the cow emoji. So I get back an object and I can call properties on that object exactly the same, as I said, as if we had just keyed in at position 2 to animals. But for a very large data set, this gives you a way to find the very first element that matches some kind of predicate. And when I use predicate, I just simply mean a function that returns a Boolean based on a test. And sometimes you don't even need the data back. Sometimes you just want to test to see if something in your data set matches a particular test, but you don't really care what it is. You just want to be like, is something there? Is this particular thing there? And so here I'm going to run a test to see if there is an animal named gorilla in my collection. And again, you have to imagine that the collection is much longer and I can't just scan it with my eyes to perform a human equivalent of this test. And I'm going to wrap this up in an if statement. I'm going to say animals. And in order to determine if gorilla is in there, I'm actually going to do a little bit of chaining. So I'm going to take 2 of these things and chain them together. So I'm going to go like animal map and visit every animal and just take that animal's name. And so what this is going to return to me now is just a collection of names. It's just going to be an array of strings. And then I can test to see if that array of strings includes the string gorilla. And if it does, then I can console.log, there are gorillas in the mist, exclamation mark. And of course there are. And so that is an example not only of using include to test for the presence of something, but also an example of some method chaining to first get something simpler to work with and then test inclusion after that. And these kind of tests, we sometimes, when working collections, that was an example of like, does this thing exist at least once in the collection? That is similar to another JavaScript function, which is called sum. And it really, sum just returns true if at least some elements in the collection conform to a particular test. And so let's imagine that all of these animals are about to compete in an epic rap battle. And based on the team of competing transformers that they're about to have this rap battle with, we know that the mana needed to successfully win this battle is 17 for each and every one of these animals. And so we're going to test to see if like some of our animals are ready for the epic rap battle. And so we'll go to the animals and we'll say are some of our animals present where the animal mana is greater than the mana needed to battle? And the answer is, I've left off a space. There we go. Some are ready? True. The question though now is like, are they all ready? Can we go to this battle? And so animals.every is going to be our new test. So visit every animal and test if every animal has mana greater or equal to the mana needed to battle. And if that's the case, console.log, we can battle, exclamation mark. And the answer is wah, wah. No battle for these animals. The cow has let them down. I guess the 5 cows have collectively let them down. They only have 3 mana, so no rap battle for our collection of animals. And last but not least of these array functions is array reductions. And the most obvious example of a reduction that is usually used to demonstrate reductions is summation. And so I'm going to show that right now. So imagine we wanted to know the sum of all of these counts, or the sum of all of their mana, for example, or the sum of all of their legs even. We could use a reduce operation to do that. And so I'll do a total count, and I'll go to the animals, and I'm going to reduce. And I'm going to pass in an arrow function that takes 2 parameters. The first parameter is an accumulator. The second parameter is going to be assigned each element in turn. And so this second parameter is going to change as we sort of visit, or as reduce visits every single one of the animals in the collection. But the total variable is going to stick around state-wise, and we can accumulate into it. And so I'm going to say that here, total plus animal count. And so what's going to happen here is for every pass of the loop, total is going to be assigned what is returned from our arrow function, which is going to be the running total plus the animal count. And then all we need to do after that is provide total with an initial value. And so here we'll start total at 0. So as we're looping through this, or as reduce is looping through our collection, total will be initialized to 0. It'll then visit the monkey, and 3 will be added to total. And then reduce will visit the dog, and 2 will be added to total, 5, etc., etc. And so if I run this code and look at the total count, we can see that we have 25 animals in total. So that's a nice, lovely way to do a sum based on the reduce method right there. And there's a whole style of programming called map reduce programming, where you can sort of break up all sorts of operations on data as a collection of map and reduce operations. And it's actually how Google does a lot of its crunching of extremely large data, because map and reduce operations are highly parallelizable. So Google can take like the billions of websites that it indexes and the billions of keywords that it indexes, and it can run map reduce queries on them across a huge number of parallelized networked computers, right? So they can sort of take their sort of internal cloud infrastructure and run really, really big map reduce jobs on that data. And so that's sort of an interesting style of programming that comes from the fact that mapping and reducing operations can be parallelized. Not paralyzed, but parallelized. Do you pronounce those things differently? I don't know. Oh, and one final reduction is just the join, and we've seen this before. If I wanted to make a guest list of all of my animals, you've seen me use join in Ruby. Here I'm taking all the animals and just mapping out their names to a name array, and then I'm going to join using a comma and a space just to make a comma delimited list, and I get for my guest list a string, which is all the names of the animals separated by the glue that I used with join. And you can also use split on a string in JavaScript, just like in Ruby, so that you could take this string and you could split it back on the comma and the space, and you could get back the array of animal names. And so that's just that's what I wanted to show with this collection of data. So the point here was to show you some useful array manipulation functions that I see being used often within React applications, and also to give you a bunch of different examples of using arrow functions with this data, each one of them hopefully demonstrating why you wouldn't want to assign a name to these things. If you are going to start writing code in this style, what would end up happening is you would have to define more and more and more named functions, and really you'd only be ever using them maybe once or twice. Like, I've used this a few times, this map just to name. Okay, maybe that could be provided with a name and reused, but it's so short that having it in line, I think, actually does make it quite readable, right? That we're mapping each animal and just preserving the name in the new collection. So I don't know about you, but I rather like arrow functions. I've got over the initial confusion that I felt when I was first using them. I still don't fully know all of the quirks of them, and there's a few places where it's sort of recommended against using them, and I'll bring one of those up a little bit later. And then again, as I said, when we get into React, I'm going to talk about how the arrow functions bind differently to the this keyword, and that's one of the places where they are also quite helpful.